Hello, in this video tutorial, I wanted to introduce the idea of logical indexing and show its utility in simplifying matrix and vector operations. Okay. Before we get started, let us review some ideas about logical relations. So consider the statement A equals 10 greater than 2. That is true, and we can see the value of A is of type logical. MATLAB represents a true statement by the number 1 and a false statement by the number 0. Okay, and so both A and B are of type logical. And we already also saw that we can construct truth tables with it. A and B, this is a logical addition. Okay, logical and, okay, A and B is false. A and B is false. The output is logical. A or B is true. Okay, these operations of and or are equivalent to mathematical operations of products. Okay, so we can also do A, the logical number A, sorry, 1 times B, that is 0, but this answer will not be of type logical. Okay, it's of type double. And similarly, A or B, the logical operation of or carries over into arithmetic in terms of this plus sign. Okay, that is true. Okay, so now let's see how we can use these ideas to simplify matrix and vector operations. Okay, so let's take a random vector of length 10. Now let's say I want to find out all the elements that are greater than 0.8 and less than 1. Okay, so I know by visual inspection that this element is greater than 0.8 and 1 but less than 1. This element is greater than 0.8 and less than 1. So first thing I can do is I can do the logical operation of A greater than 0.8. Okay, so all these numbers satisfy that constraint. Similarly, I can do A less than 1. Okay, and all those numbers satisfy that constraint, which was obviously the case. But notice only these two elements satisfied both the constraints. Okay, we eventually want to get only those two elements. Okay, before I get to that part, let me just show you another side, a little bit of a trick where I can use these as indices to selectively sample elements of a matrix. Okay, so I can take, that was my logical relation. The answer is of type logical, but I can treat these numbers or treat the places where they occur as a way to index and obtain elements of a vector. So I can do the following operation, and MATLAB will spit out all the elements that were greater than 0.8. Okay, let's try another example. Let's say between some numbers, a number that is less than 0.2. Okay, A of A less than 0.2. Just one case, maybe 0.4, couple of cases. Okay, so now let's get back to the problem of finding out the total number of elements that were within some range. Okay, so let's say 0.8 and 1. So those were the numbers that were greater than 0.8, and those were the numbers that were less than 0.1. Okay, what I want is essentially this operation. Okay, I want all the numbers that are greater than 0.8 and they satisfy the constraint that they are less than 1. But if I do this, if I write a statement like this, MATLAB will complain and give me an error, because whereas I can do a logic term by term comparison like this, I can do a term by term comparison like that, MATLAB doesn't like us to combine these two logical vectors term by term like this. Okay, so a solution to that, and as I just showed above, the logical addition, or the logical and rather, is synonymous with multiplication, is synonymous with the operation or mathematical operation of multiplication. So I can do a term by term multiplication and obtain all those terms that were greater than 0.8 and less than 0.2, and I can do that. So two elements of this matrix satisfy the constraint of being greater than 0.8 and less than 1. Okay, and similar I can do some other cases, say let's greater than 0.2 and less than 0.5, 0.4 for example. Okay, so 9 elements satisfy those constraints. What I can do, okay, what I can do, oh sorry, 0.4 was a bit short. So what I can do is I can use this idea to construct a histogramming program. Okay, and the program I've written is essentially here. Okay, where what I do is I have a big data vector. Okay, that's my input data. I'm going to show you an example. I'm going to construct the lower bound and the upper bound of the data, and how I want to partition the number line. So pictorially, this is what I want to do. I have a number line, and in this example, I'm going to partition it in terms of width of the number line. I'm going to divide it into units of 0.05. So 0 to 0.05 is one bin, 0.05 to 1 is another bin, and so on. Okay, and I essentially find the range that I have to sample, and I'm essentially creating vectors to hold the numbers, and I define the margin of each bin. So for example, the margin of this bin is 0.05 to 0.1. Okay, and I use the trick I just showed you to find the number of counts, and the midpoint of a bin is essentially the middle of, in this case, the middle of this interval, for example. Okay, let me just show how I can use this by applying it to a large random vector. Let's first do a uniform random number. Okay, so A is so. Then I find the midpoints and the probability distribution, bin data. Okay. A is my random number. The lower margin is 0. The upper margin is 1, and I want to divide the numbers in units of 0.05. Okay, and I'm going to set, before I plot, I want to make an axis which goes from 0 to 1 on the x-axis and 0 to 1 on, sorry, 0 to 1 on 0 to 2 on the y-axis. Okay. Okay. And then I'm going to plot midpoints probability. I should see something that is roughly a straight line. Okay. It is a straight line if I make the units correct. Okay. If I do it that, so you see it's roughly a straight line. Okay. Roughly constant. That's what I mean. Not a straight line. Roughly constant. Okay. I can certainly use MATLAB's intrinsic function called histogram, but as I have indicated, I typically try to avoid canned routines if I don't know exactly what they are doing. Okay. So this approach that I have just showed you is very useful for making histograms of real numbers. Okay. So maybe in the next video, I will show you how to take this idea and apply it to histogramming integer numbers and trajectories. Okay. Thank you.